Hello everyone, welcome back to my channel Indu Biotech. Hope you all are well. As I discussed in the earlier video about the disulfide by design 2 tool and why we do use this tool and how we access. And now today we will learn how we will read the result of disulfide by design 2 tool, which will clear by watching this video properly. And let us start the main topic. We already learned in the previous video how to assess the disulfide design 2 tool for find out the disulfide bond in any given protein sequence. So I will not go in details for that, directly come on the result section, right? So we'll come on the result section. Quickly we revise the previous lecture. First of all, we type the disulfide by design 2 in browser and click on this one. After clicking this one, we add the PDB ID of the interested protein. Here I add 7RSA, the protein PDB ID, and click on the get from RCSB. Here the general information of the protein will be appear, and after that we'll directly click on the run and we'll get the results, right? Here result is appearing, and this is the residues 1 and residues 2. That means residues 1 and residues 2 means the amino acid 1 and amino acid 2 that form the disulfide bond, right? And this protein has the one chain, single A chain, and this the second sequence column represent the position of amino acid, this the alanine residues is present at the 28th position of the amino acid, and cysteine present at the 26th position. Like this, the threonine present at the 36th position, and histidine present at the 48th position, and it form the beta sheet, right? Same in the residues 2, the tyrosine present in the same amino acid and at the position of 25, and it form the alpha helix, and cysteine present at the 84th position of the amino acid in the same chain A, and it form the sheet, and it also form the sheet strand. And this one is the chi. As I told in the previous lecture, chi means the torsion angle that ranges from the minus 87 to plus 87 angstrom, or we can choose plus minus 30 angstrom from here. And thus it is very important to know and remember that the value of the torsion angle shows high probability of the disulfide bond formation, right? As you can see the positive value, this one is the positive value of the amino acid, means this amino acid showing having the more capacity to form the disulfide linkage. Next one is, it is the kilocalorie per mole. Basically this is the bond energy of the amino acid, and this range is approximately 0.89 kilocalorie per mole to 8.35 kilocalorie per mole, right? So please remember the range of bond energy. I am repeating again, it is 0.89 kilocalorie per mole to 8.35 kilocalorie per mole. Next one is the beta factor that I have already discussed in the previous lecture. That beta factor, also called the temperature factor or displacement factor, and it ranges from the 20 to 40 angstrom. So here you can see all the value of the beta factor is present between the 20 to 40 angstrom and play important role, and the beta factor play important role in the crystallography of the protein. So we can read the results as the alanine that present at the position of 20 and form disulfide linkage with tyrosine that present at the 25 position, and value of the torsion angle is minus 91.82, and the bond energy is 1.43, and the value of beta factor is 22.40 angstrom, right? In this way, the cysteine amino acid cysteine residues present in the same chain A and at the position of 26 in the and its structure is the alpha helix, which can make the disulfide bond with the another amino acid, that is cysteine residues, which is present in the same chain A and at the position of 84 and it involved in the sheet formation, right? And it's all these torsion angle and the bond energy beta factor are the property of disulfide bond of the residue 1 and 2. Thus in this way you can analyze the result that is given by the disulfide by design two tools, which amino acid residues can form disulfide bond with which another amino acid residues, right? And what is the property of the disulfide bond? That means zeta 3 value, kilocalorie bond energy and beta factor, all these three are the properties of the disulfide bond. And about the secondary structure, and the 3D view, I have already discussed in the in very details to in the previous lecture. So please go through the previous lecture one, and the link I will provide in the description. So for the today's the overall and see you in next video. Thank you so much.